In this example, we have a 20 ohm resistor and a 60 ohm resistor connected in parallel, and we'll call R1 here the 20 ohm resistor and R2 here the 60 ohm, and they're connected in parallel with a 120 volt power source. We're told to find the voltage and current in each resistor. Well, the voltage is pretty easy. We remember that in parallel the voltages are the same, so V has to equal V1 and that has to equal V2, and that's going to be 120 volts. So V1 is 120 volts and V2 is 120 volts. They're the same as the voltage here provided by the battery. We can use that fact to find the current in each resistor. Using Ohm's law, V equals IR, and just solving that for I is V over R, we can say I1 is V1 over R1. And we know the voltage is 120 volts, and we said R1 is the 20 ohm resistor, and 120 over 20 is 6. So that's 6 amps for I1. I2 will be V2 over R2, and that'll be 120 volts over R2, which is 60 ohms, and 120 over 60 is 2, so that's 2 amps. So 6 amps and 2 amps. So what we imagine is current coming out of the battery and dividing at this point right here, and 6 amps going down this side and 2 amps going down this side. Now note that the smaller resistor, R1, was 20 ohms compared to R2 over here, which was 60. The smaller resistor got more current, and that should make sense. The bigger resistor, the one with the higher resistance, resists the current flow more. So we only have 2 amps, a smaller amount of current going through the larger resistance, through the resistor with the larger resistance. Now in part B, we're told to find the total resistance and the total current for the circuit as a whole. Okay, let's find the total resistance, and we'll use our formula for total resistance, and that's 1 over R is equal to 1 over R1 plus 1 over R2. And we'll put in the numbers here. This is 1 over 20 ohms plus 1 over 60 ohms. And those are going to be pretty easy to rewrite with the common denominator. 1 over 20 is the same as 3 over 60. So 3 over 60 ohms plus 1 over 60 ohms, that obviously adds up to 4 over 60 ohms. And that's 1 over R that we just found. So R will be the reciprocal of that. So R is going to be 60 ohms over 4, or 15 ohms. That's the total resistance. And in the problem it said, find the total resistance, we just did that, and the total current for the circuit as a whole. So the total current will be found with Ohm's law. V is IR, but we're going to algebraically solve it for I. I is V over R. And we put in the total voltage, 120 volts, and the total resistance, 15 ohms, and 120 divided by 15 comes out to 8 amps. That's the total current. Now this should make sense. That number 8, you should see back here on our earlier calculations, we had 6 amps in one branch and 2 amps in the other, and that obviously adds up to 8. If the current divides right up here at the top at this point, and 6 amps goes down this branch, and 2 amps goes down that branch, then the total current coming into that point had to be 8 amps. And so we see resistors in parallel, the voltages are all the same, and then the currents add up to the total.
Hi, in this screencast we're going to look at a simple DC circuit and see how we can apply it to Ohm's law and Kirchhoff's law. So here's the circuit. We have R1, so current will come out of the battery, flow through R1, then it's going to split. So when the current splits, we know that the resistors are then in parallel. Okay, so the current splits here, what it's telling us is this resistor, R2 and R3 and R4 are all in parallel. The current then comes back together down here and flows through R5. So we know that from that R1 is in series with these guys that are in parallel, which is in series with this resistor. And maybe if we look at that circuit drawn in another way, we can visualize that better. So here's exactly the same circuit. Current comes out, goes through R1, then splits. Current will go through R2, some will go through R3, some will go through R4, and then go back through R5 and back in. So from this we can see that R1 is in series with these guys that are in parallel, and this is in series with these as well. So let's look at some calculations then. So here's our circuit, and there's our currents. So IT flowing through here, that allows I1 to come down through that resistor, I2 to come through R3, and I3 to come through R4. We know that when resistors in parallel, the generic equation is 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So in this case we're looking at these three resistors. So the total resistance for the parallel network is 1 over 5600, so 5K6, 1 over 4700, 4K7, and 1 over 3300, 3K3. Put that into a calculator, you will find that RT is 1440 ohms, which means I could replace all those resistors with this single 1440 ohm resistor. The total resistance of the complete circuit now is R1, which is in series with 1440, which is in series with R5. So the total resistance is R1 plus R2 plus R3. That's the generic equation. So in this instance, that's 1000 plus 1440 plus 1000, which gives me 3440 ohms. So we can visualize that. We have replaced these three resistors with this single 1440 ohm resistor. Now if we want to do some calculations now, I know that the total resistance now is 3440 ohms, therefore I can calculate the total current. And the total current IT is equal to V over R total, so Ohm's law. That gives me 28 volts divided by 3440 ohms, which is 8.14 milliamps. Because this is a 1K resistor down here and IT is also flowing through that, I know that the voltage down here is also, or current down here is also 8.14 milliamps. Now I'm looking to find out what voltage is dropped across this 1440 ohm resistor. Well, I can do that by using Ohm's law. So Ohm's law is V is equal to I by R, so the voltage is equal to I, which is 8.14 milliamps, the total current, multiplied by the resistance, 1400 ohms, 1400 ohms, yeah, and that gives me a voltage of 11.72 volts. Now, if I want to calculate the currents, I know that I1 is equal to 2.1 milliamps, because it's 11.72 divided by 5600. Similarly, I2 is 11.72 divided by 4700, gives me 2.5 milliamps. And I3 is 3.5 milliamps.